Okay, so let's take a look at number 9. We had a question about that today in class. And I think this is, this is section 6.4. Okay, so we want to find the sine of u minus v, and you might remember that this is going to be the cosine of u sine of v minus the cosine of v sine of u. Now, we definitely have places that can be substituted for immediately, but keep in mind that the cosine of u, we don't know what that is. We have the cosine of v, but we don't seem to know the cosine of u, and we might have the sine of u, but we don't seem to have the sine of v. So this is where some of our identities will be helpful. So for example, I don't know what the cosine, we don't know what the cosine of u is. Why don't I call that a big X? So this will become x squared. So I'm going to have sine squared of u plus x squared equals 1. And we know what the sine of u is. It is 12 over 13. So we square that. And that gives us now an arithmetic equation. No more trig. This is just solving an equation. So we're looking at 144 divided by 169 plus x squared equals 1, which gives us, if you make the 1 into an appropriate fraction, or 169 over 169, and subtract 144 over 169, we're going to get 25 over 169, which is in fact, what was x? It was cosine squared of u. Now, we're going to want to take the square root of both sides, which gives us plus or minus 5 over 13, right? So we're taking the square root of both sides. We don't need a plus or minus here. So now we're looking at choosing the plus or the minus. Keep in mind that this states that both are in quadrant 2. Well, we know that sine and cosine, sine is going to be positive in quadrant 2, but cosine is going to be negative. So that means we're going to choose the negative for the cosine of u. So in place of cosine of u, we're going to put in negative 5 over 13. Let's fill in what we already know. Cosine of v is negative 3 over 5. Sine of u is equal to 12 over 13. And now we need the sine of v. We'll use the same idea again, where sine squared v plus cosine squared v equals 1. They both have to be v's. You can't swap the u's and the v's. And now we're looking for the sine of v, so we'll call that capital Y, so that's y squared. Just calling it y so we don't confuse it with the x. And the cosine of v is negative 3/5, which we're squaring, and that should be equal to 1. Please be careful when you go to do this multiplication. It's negative 3 over 5 times negative 3 over 5, which gives us positive 9 over 25 plus y squared. And so we end up with y squared equals, we'll write the number 1 as 25 over 25 minus 9 over 25, which will give us 16 over 25. And since we're looking for y, we'll take the square root of both sides, and y is in fact sine, so we get the sine of v equals plus or minus 4 over 5. Plus or minus 4 over 5. How do we know which one to choose? Well, we're in the second quadrant. in quadrant 2. Sine is positive in quadrant 2. That means we're going to go with plus 4/5, and we're going to put the plus 4/5 in there. So the key to this is you really need 4 items. You're going to be given 2 of them, and to get the other 2, you're going to use the Pythagorean identity. So when we put this together, we're going to get negative 20 over 65, which is 5 times 13, plus 36. So that should give us 16 over 65. Okay. And let's complete that for now and post it. Oh dear, I found one slight mistake from the beginning. This, in fact, this should have been VU UV. So that means that our answer is fine. We just want the opposite of it. Okay? All right,